Can you hear me? Yeah. Okay, we are live. Good evening, everyone. This is Timi, Uluwatimilai, in long terms. So the topic of today is a retrospective of object-oriented programming and an introduction to protocol-oriented programming. Too much English. Basically, a throwback of object-oriented programming, and then me seeking to introduce a relatively new programming paradigm. That being said, disclaimer, this is not a versus. This is not saying object-oriented programming versus protocol-oriented programming. This is just a throwback and an introduction. So, object-oriented programming. What is object-oriented programming? Anyone? Can anyone answer what object-oriented programming is? Wale? So it's basically just a language model that's organized around objects rather than data, and action. Objects rather than actions, and data rather than logic. It does not mean we don't use actions. It basically just means we don't write things in a linear structure. So we try to group attributes together and then find a way for objects to relate together with themselves through that. So down to the most asked question in any interview. What are the principles of object-oriented programming? Abstraction, encapsulation, inheritance, polymorphism. Okay. So we go with abstraction first. Basically, what abstraction basically does is that it takes complexity, and then it just takes on complexity by trying to just expose basically high-level mechanisms that the client needs to use, right? And so basically all what the user of the object sees is what he needs to use. He does not need to know anything about the internal state of the object or anything that goes through with that. Yeah. And that's pretty important because a lot of people always try to think that abstraction and encapsulation follow each other. They work together, but they are not the same thing. So it's basically achieved using protocols in Swift, and in Java, you use abstract classes and interfaces. Encapsulation is basically the idea of building data and methods that work together in one unit. Basically classes or structs, if you write Swift, or enums. So basically, you're just trying to hide the internal representation of the object from the outside. Basically, we use access modifiers for encapsulation. And then we go to inheritance. Basically, the process of creating a class based on an existing class in which the class you're creating has all of the attributes that are allowed by that existing class here. So it's a very, very nice feature to have in that it basically allows for code reusability. You don't necessarily have to write things twice. Thanks to inheritance, we then have this polymorphism, which I'd say is, to me, is the most interesting part of the bunch, because what you're basically saying is that an object can basically take on multiple forms, right? And how is this achieved? This can be, so polymorphism can be achieved in three ways. Basically, for most language, they are dynamic and basically dispatches during compile time. So that means they are basically errors. They are basically things you are not conforming to that class if you are not conforming to the class pass. So an example of a static dispatch would be, say, an interface. If you if I have the time, we can try to. We can try to. I can try to show basic of a very basic example of dynamic dispatch. So let's say we have a class distribution. And then the class distribution. Let's say we want to take a sample. So we say sample doesn't take any parameters and it returns a double. So because in Swift, abstract classes are not allowed, so we can just tell it to throw a fatal error during runtime. So as to basically just model the behavior of an abstract class. I should zoom in now. Yes, I'm trying to check. Okay. Live will put on. Okay. Then let's also have a second method that basically just takes all our random, all our samples and gathers them into an array. So we can should be an overriding, and then we can define counts for the amount of times it should do that. Should return an array of doubles. Okay, so this is a simple class, and what it basically does is you specify a sample, yeah, a random sample, and then it takes that random sample and then it just merges it into an array and then returns a double array. So say we have another uniform distribution class. And then the class conforms to distribution. So first to test the static dispatch, it means that basically if we try to initialize this guy, any method that this guy tries to call should fail here because it is being defined statically. Right. So if we come down here and then we do let's uniform distribution. Call and then we'll try to do a uniform distribution dot sample and then we specify 10. This should give us an error, right? Because it is looking through the V table, and this is the only implementation of double it can find. And so you can see the error, class not overridden. Okay. So let's say for uniform distribution, we just want a random number, a random group of numbers in which the probability of calling each and every one of them is equal. We can do what should we call it? By range. And then we can specify an initializer. Yes. Okay, so we specify the range. Then we can come here and then just override this method. So, and then for this guy, we can try to return and start from closed range. Okay. So of course this guy is going to get hungry. So for new objects, we can specify a closed range. So let's specify like a dice. So the 6 faces of dice. Okay. And so when we run this again, sorry, let me cancel this. Okay. So we can see it here. I don't know what's wrong with Playground right now. We can see it here that it prints out the number. So basically what's happening here is that it's looking through the V table for this guy, right? It's looking through the V table and then it's picking our implementation of this method, of this override here. And basically what polymorphism allows us to do is get a little bit crazier. So basically I can simply just define a distribution of type distribution. Basically just equate it to just remove all of this, and basically just equate it to a type uniform distribution. Let's make a new range 20. So we are saying pick a random number from ranges 1 to 20. Sorry. Pick a random number from 1 to 20 and just add it to an array. Add it to an array that would output out. And we can basically call distribution dot sample count 10. And this time it prints something. While it is running, you can see here. So basically, what's happening here is that we are telling that this guy is type distribution. So it's supposed to be of this type. But yet it is not calling this guy because the object, this particular object, can take on different forms, right? And that's a very, very basic example of dynamic dispatch. That is, during runtime, it looks through the vtable and then it picks the method. Okay. So now that we're done with that, dispatch. Okay. Introducing protocol-oriented programming. So in protocol-oriented programming, we are basically what we are saying is that we are designing our systems using protocols. For PHP writers and Java guys, it's basically like starting, instead of using a base class, you are using interfaces this time around. And what are protocols? Basically, like interfaces, the blueprint of methods and properties, and other requirements that suits a particular task. And so, what's the difference? What's the main difference between using a protocol and a class? So the main difference is that instead of using a vtable during runtime, protocols use a witness table. The problem with a vtable is that a class can only have a single vtable, and this results in the fact that you can only inherit from one class, right? You can only ever extend from one class. Meanwhile, for protocols and interfaces, you can have as many witness tables as you want. So that means you can basically inherit. Basically, you can adhere to multiple protocols at a time. And what this impacts in Swift is that in Swift, we tend to prefer value types over reference types. So that means we tend to prefer structs and enums over classes. But the problem is that inheritance does not work well with structs because it is a value type. Let's call this B original. Call this B. Let's also make it 10. Okay, then we can have if so you can have a copy to be equals to a original, and we can have b copy to be equals to b original. So let's say we now decide to change a copy dot a, which is our reference type, to 20. And then we decide to change b copy dot b, which is our value type, also to 20. And then we come down here and then we print out a original dot a for some records. And we also print b original dot b. So remember, b is our value type and a is our reference type. Okay. Yeah. A. The exclamation. Yeah, it's optional in Swift. And so basically I'm just telling it to force unwrap it. But so we can see from here that the reference type, what it is basically doing is that it's holding a reference to the value, right? So that means anybody else, like a copy, can come in there and change that value to 20 because it is a reference to that value. It is holding a reference type. But B, on the other hand, which is a value type, does not change because B copy B is entirely on its own. It's entirely different from A original. So a struct is a value type, a class is the reference type. So one holds the reference to the value, another holds the value. You get? So, okay. I hope I got you. So the main problem is that structs and enums do not work with your traditional object-oriented programming paradigms, and that's because inheritance does not work with structs. But what can they do? They conform to protocols. So you can create as many witness tables as you want. So if we go back to our original example of uniform distribution, and say we want to take a protocol approach, a protocol-oriented approach. So, like we said, you start by defining your protocols. So we can have a protocol distribution. Then we define sample. So to return a double. And we can also have a second sample. Counts double. And this returns an array of double. So one of the many advantages that protocols give us is the fact that we can specify default implementations for a protocol object, right? So basically, what I'm saying here, I can come down here and do an extension of distribution. And then basically, so I can create what's the name? I can create a sample Sample points. Step here should be integer. This one should always be an integer. And then still gives us a double array. And basically it's still the same thing. I'm just returning all of the elements. Okay, so basically what I've just done here is to find a default implementation for this guy here. So that means I'm saying that you don't necessarily have to, for any guy that tries to conform to this protocol, if you don't override this method, this is what should be used instead. So now we can use our value type, which would not have worked because they don't like inheritance. We can use our value type of struct. Let's call it uniform distribution again. Distribution. And it's of type distribution. Again, we specify a range to be a closed range of integers. So we can basically call sample. Yep, and then just tell it to return basically the same thing. A random double. And then it takes in a range. Okay, and we can basically come down here. Let's make it D10 this time because this time our struct takes in the value of range 1 to 10. And then we can simply call D10 dot how many times? 10 times again. So let me just print this. Okay, so again, we can see that that works nicely. If we like, we can simply just decide to actually just override the default implementation and then decide to actually just return for every single one. If we decide to simply just return double, right? The amount double. So we could simply just do another override here. For example, counts, and tell it to return all the way down to counts. The map. Again. Multiplied by 2. Right. And the difference is that our range, we are trying to pick a range from 1 to 10. So that means all of our values should be multiplied by 2, and we should at least have some values that are not in this range in our arrays. So it's done. And so here, So here we've been able to specify a custom implementation, and we're telling you to use the custom implementation rather than use the default implementation. Okay. You want to go back to struct, they are value types. So they don't support inheritance because they are value types. You get, because they hold the real value. So it's sort of like inheriting, it has to do with reference types, right? Because if you're holding the real value, that real value should not change except you are changing it. Yeah. And inheritance is saying, okay, conform to me. And then at runtime, I can change you. Right? Do you get, like, that's the normal inheritance. So inheritance is saying conform to me at real time. I can decide to swap out my implementation, but value type is saying no, I can't change because this is who I am. This is the real value. It's not a reference.
So the way to go over that in protocol is through the extension.
It's through the extension.
Okay. So you're saying even with this struct now, if you put an extension and
In this extension here, what we are just doing is we are defining the default guy. So we are defining the default implementation. And what that means is that it's not using a V table this time around, it's using a witness table. And so it's going to check through the witness table of this struct. If it does not see this guy here, then it's going to know that, okay, the guy is conforming to have a default implementation. And then it's going to use that instead.
the only way you can do the default implementation is through the extension.
Through the extension, because basically what you are saying the only way you can do it is through the extension. The extension is basically just a way of, it's just a tool to reopen the class. It's just you would see more about on how you can use the extension.
So what makes this a protocol?
This guy here. So this is the guy, and he's conforming to this particular guy. Okay. Thank you. Okay. So now that we know about protocols, there's an interesting bit of magic that Swift allows us to do with protocols, and it's called retroactive modeling. And basically what retroactive modeling allows us to do is that we can take two types that are not related in any single way. Okay? But because of protocol-oriented programming language, we can handle them the same way. And why is the reason? It's because it allows us to build a new interface after the fact. So that means I can build a new interface even after the fact that you've created your class. I can specify So what that means is that I can specify a new witness table. What that means is that I can specify a new witness table for an already existing class. I don't know if anyone got that. Like, your class can be existing, and I can specify a new set of rules that it can adhere to, a new set of methods that it can run. Okay, and that is what protocol allows us to do. So let's dive right into it, because the best way to explain that is by saying, actually, let's start again. Import foundation. Okay, so this time around we are going to start with we'll start with two structs. Okay, because structs are value types. so you don't say I'm using references to scam you. So I can create a struct circle, and what should we put inside the circle? We could simply just put we could put an origin after a double, and then we could also put the radius. Of course, every circle has to have a radius after a double. Since we are creating shapes, we can go. Sorry, struct. We can create a rectangle. Huh? Oh, rectangle. And so this guy can have origin, can have a double, and we should have heights, a double also, width. I think that completes. I think that completes. So basically, we can create new instances. So let's put circle equals circle, and there we go. Origin 0, radius 10. And then we go over. And then we go over rectangle. Rectangle equals. Oh, sorry. Equals rectangle. And then origin is usually 0 for most of these guys. Yeah. So, and then double should be height should be, we could put 100. Width we could also put 100. Doesn't really matter. So let's say we want to create the area for. Sorry, we want to get the area. We want to get the sum of the area for these two guys. What's the best way possible? So what we'll probably want to do is write a method inside of these two guys, right? And then call those two methods separately and then add them together separately. What if I told you that we could simply just handle all of them in one common manner? And what's the manner? We could simply just make sure that they both conform to, say, a protocol geometry that forces you to have, that forces you to have an area that returns a double. Okay, so we could simply just come here, and this is where retroactive. I can create an extension, right? Even after I have created the classes, to tell this guy that, okay, I want you to conform to this new witness table. Yeah. So I can write something like this. I can extend circle. Okay, it's extend geometry. And anytime area is called, I want you to do this. The area of a circle, for those that have not forgotten school, is pi r squared. Right? So pi times radius. Notice how radius comes because I'm extending circle, so I have access to its fields, right? Yeah. And then I can easily go extension, rectangle, geometry. Also extending geometry, and then I can do area and tell it to return area of the rectangle is height times width. Length times area. Well, you get the idea. So right now, I can, thanks to the fact that they are all shapes, so we can create an array of type geometry that contains a circle. And this is polymorphism at work here, right? Because I should not have an array of another type, because they are two completely different. Shape. And so basically, these two guys have nothing in common. Or if I told you, we could simply just do a reduce function. We could simply just print shapes. Let's reduce. So we could reduce it to a sum of. We could reduce it to a sum of itself. Don't mind the language specific units. I'll just need one unit and you get it. So basically, what I'm just saying is that for every single guy in this area, add them all up together. For every single guy in the array, add up all the area. And if we run this, voila. So basically, what we've been able to do here is take two completely unrelated classes, circle, rectangle, that have nothing in common. We made them have something in common, even after they had been created. Please note that I had created circle and rectangle before I defined this protocol. I was able to define a protocol. I was able to give them a relationship. So we made them from strangers, from total strangers. We made them acquaintances at first by defining, okay, you guys like this, you guys like this. And then by making them acquaintances, we are able to even make them closer and become best buddies by doing this. And that, my friends, is retroactive modeling. And you actually really see the use, especially when you are actually dealing with code that is not yours. You are dealing with source codes that are not yours. You could easily extend anything from a string class in Swift to an image class in Swift, really. Yeah. So, like I said, we can always create a new witness protocol for every single time. Conclusion. Presentation is just to remind us of how awesome some of the concepts we use in our everyday life. I'm pretty sure we use polymorphisms in ways that we don't even think of. And basically just to introduce us to a new paradigm, protocol-oriented programming. This is in no way WINA versus OOP versus protocol. All right, thank you. I hope you don't get bored with my very technical thing. You guys are welcome. So questions, comments?
So think about classing and instruct.
Okay.
You said a value type, so that means in Swift is a class is not
It's not a value type. It's not the same as a struct.
No, it's not the same as it's not a value type or it's a value type but not the same as struct.
A class is not a value type. A class is a reference type. So what we are saying is that we have a class. Yeah, let me explain to you this way. How do I explain it? So you have this guy. I think I can hold on to it. So you have this guy, right? So you're a class. Let's say you created this guy. But Even after you created it, all you have to it is a reference. All you have to it is a connection. You just took your cup and you poured it. You are not the owner. Yeah? So that means someone else can come here, take out of it, or add to it, or even add something else to it. Anything else.
My question is it the same as the normal, in other languages, what classes are?
No, this is basically Swift.
Okay, Swift.
This is basically Swift. I'm not sure about other languages, but usually most other languages it's reference type really. It's reference type.
Yeah.
It's like class example.
It's like class example. It's just a. Is there? Do you understand what the meaning of a reference type is?
Yeah.
It means all I have is an address to that guy. I am not the owner of that guy. So it means that basically, if I say class A, if I say A equals to a random object, right? And then I come back and say B is equal to A. Basically, what I am saying is that B and A have addresses that connect to that particular object.
You know what I'm asking is using PHP now, you can't have multiple classes in one.
Oh no, take your mind away from.
Oh, so here you can. You see,
take your mind. I'm not even talking about. So basically, what we are talking about is like implementation. You can have inner classes. Control the outer class, they kind of has control. Java.
That's actually why
that's why
because I noticed that you're doing like classes, wow.
So that's file. So I think what you're even talking about is file types. File types are different. It's just like Swift file type is like JavaScript, where you can just have multiple. You can basically write your entire application.
You can actually have functional scripts like
yes.
Without just like talk down.
So basically, what allows you to have all your functional is the dispatch method used, whether it is static or dynamic or objective.
Sorry, just a comment. I think that another good thing about this, like brevity of, so you're able to do that stuff like this circle, rectangle, but normally someone would want to probably do another function, something, but that just tied it. I think we use that a lot on our projects, so I think it's like a good concept that can take to other places like PHP.
You guys still have inheritance.
If I'm right, there is a way. What do you know about traits in PHP?
Yeah. That's a good one.
Traits will give you. If I understand the concept, traits will give you the same thing.
Yeah, but in the end, I think the usual problem is that.
Just makes sense actually. But okay, if I understand now, I think the difference between you stop in Swift and working that you can. I'm not sure you can write an extension function for an application.
No. So that's the beginning point. So in fact that it's one of the reasons why I can't. But if you think about it, you don't necessarily need to write extensions in Kotlin because you already have abstract classes. You get. So you can basically, although you might not probably be able to do the retroactive modeling, but no, you won't be able to do it.
Also, you mentioned something about this multiple inheritance. I know people
enables multiple inheritance.
So C++ does not use
dynamic dispatch. C++ uses full message. C++ and Objective-C actually, they use full message dispatch. And full message dispatch is very flexible. In that you can actually even break in an entire. So in dynamic dispatch, what you are simply saying is that this method or this method, yes, run this one, don't run this one. In Swift, you can bring in an entire new implementation. Like you can bring it in and then tell it, okay, run this guy entirely instead of running this guy. So I actually looked into it, but it was very much. I like it. I like it. Thank you very much. References. My new reference was Revolution.
My guy.
You talk with a page,
Blog.
tutorial sites. But if you're interested in